Special triangles and the unit circle. In this video, we are going to discuss the special triangles such as 45, 45, 90 degrees, the 30, 60, 90 degrees and the 60, 30, 90 degrees triangles inside a unit circle in a Cartesian plane. Here we have a triangle in which the angles measure 45, 45, 90 degrees, and this is called an isosceles right triangle because two angles are equal, thus the two shorter legs are also equal in length. Thus if one side measures x length, then the other shorter leg measures also x length, and if we let h be the hypotenuse, so h squared is equal to x squared plus x squared. Simplifying, we have h squared is equal to 2x squared, and by getting the square root, h is equal to the square root of 2x squared, so we have h is equal to x times square root of 2. So if the two legs of the 45, 45, 90 degrees triangle measure x in length, the hypotenuse is x times the square root of 2. To have more understanding, we are going to have an example. Example: if the shorter leg measures 7 units, the other shorter leg is also 7 units, and the hypotenuse is equal to 7 times the square root of 2. 7 times the square root of 2 is approximately equal to 9.8995. But sometimes it is better to remain in the form 7 times square root of 2 and avoid approximation. Back to the equation, h squared is equal to 2x squared. Suppose we are given the hypotenuse but not the legs, so interchanging, we have 2x squared is equal to h squared. Transposing 2 to the right as divisor, so x squared is equal to h squared over 2. Getting the square root, we have x is equal to square root of h squared over square root of 2, and it's equal to h over square root of 2. Rationalizing the denominator, so multiply both numerator and denominator by square root of 2, so it's equal to h times square root of 2 over 2. So if the hypotenuse is given and the legs are unknown, so it can be solved. This is h times square root of 2 over 2. Example: if the hypotenuse is equal to 1, so the shorter legs are 1 times square root of 2 over 2, and 1 doesn't affect anything, so the shorter legs are equal to square root of 2 over 2. Incorporating this with the unit circle, in which the center is the origin and the radius is 1 unit. Assuming this triangle inside is 45, 45, 90 degrees, so the x and y coordinates of the radius of triangle or the tip of the triangle are both square root 2 over 2. Both x and y are both positive, for it's in the first quadrant, but in the second quadrant x coordinate is negative and the y is positive. In the third quadrant both are negative, and in the fourth quadrant the x is positive but y is negative. This figure shows the coordinates and the angles in both radians and degrees. For 45 degrees or 1/4 pi radian, the coordinates are both square root of 2 over 2 first quadrant. For the second quadrant are the 135 degrees or 3/4 pi, in which the x coordinate is negative but y coordinate is positive. For the third quadrant on the 225 degrees or the 5 over 4 pi radians, the coordinates both x and y are negative square root of 2 over 2. And on the fourth quadrant, at 315 degrees or the 7 over 4 pi radians, the x coordinate is positive square root of 2 over 2, while the y coordinate is negative square root of 2 over 2. The next special triangle is the 30, 60, 90 degrees triangle. This is a scalene triangle, for no angles or sides are equal. The unique about this triangle is that the shortest leg opposite to the 30 degrees angle is 1/2 of the length of the hypotenuse. If you multiply the shortest leg or side of this triangle by 2, you can have the length of the hypotenuse. Let h be the length of the hypotenuse, so the shorter leg or side is 1/2 h or h over 2, and let x be the length of the longer leg or side. We can use in this the Pythagorean theorem as x squared plus quantity h over 2 squared is equal to h squared. Transposing quantity h over 2 squared to the right, we have x squared is equal to h squared minus quantity h over 2 squared. Getting the square root, we have x is equal to the square root of h squared minus quantity h over 2 squared. Simplifying, we have x is equal to the square root of h squared minus h squared over 4. Making the inside of the radical similar fraction, we have x is equal to square root of 4h squared over 4 minus h squared over 4. Subtract the numerator, we have x is equal to the square root of 3h squared over 4. We can get h squared over 4 out of the radical sign, so we have x is equal to h over 2 times square the root of 3. From this we can say that in a 30, 60, 90 degrees triangle, 1/2 of the hypotenuse is the length of the shortest leg while the longer leg is 1/2 of the hypotenuse times the square root of 3. And if the length of the hypotenuse is 1 unit, the shorter leg or side is 1/2 while the longer leg or side is square root of 3 over 2. This 30, 60, 90 degrees scaling triangle can be also made into a 60, 30, 90 degrees triangle. Just take note that opposite to the 60 degrees angle is the longer leg or side while opposite to the 30 degrees angle is the shorter leg or side. The values we obtained by letting the hypotenuse equal to 1 is very important in the unit circle with radius 1 having the 0, 30, 45, 60, 90 degrees, or the special angles and so on. These are the coordinates of both x and y in a unit circle. Here in the 0 degrees, x is 1 while y is 0. In the 30 degrees angle the coordinates are for x is square root of 3 over 2 for the y is 1/2. For 45 degrees the coordinates are both square root of 2 over 2. For the 60 degrees the coordinates are for x 1/2 and for y it's square root of 3 over 2. For the 90 degrees the coordinates are, for x it's 0 and for y it's 1. In the second quadrant for 120 degrees or 2/3 pi radian the x-coordinate is negative 1/2 while the y-coordinate it's square root of 3 over 2. For the 135 degrees or the 3/4 pi, x is negative square root of 2 over 2 while the y it's positive square root of 2 over 2. For the 150 degrees or the 5/6 pi radian, x is negative square root of 3 over 2, for y it's 1/2. And for the 180 degrees or pi radian, x is negative 1 y is 0. Opposite to the first quadrant is the third quadrant. In the first quadrant all coordinates are positive so in the third quadrant all coordinates are negative. And opposite to the second quadrant is the fourth quadrant. In the second quadrant x is negative and y is positive since opposite so in the fourth quadrant x is positive y is negative. Angle measurements are with respect to the x-axis, so notice that 30, 150, 210, 330 degrees have the square root of 3 over 2 and 1/2 but differ in sign. 60, 120, 240, 300 degrees have 1/2 and square of 3 over 2 but differ in sign.